My name is Han Lee. I am the Director of Data Science at Moody's, and it's a privilege to kick off the foundation model track here at Data Council 2025. So before we start, a quick disclaimer. The views expressed here are my own and does not present that of my employers. So these days, we're going through a world of extremely rapid AI innovations. And the big question is, where is the real value being created? And my thesis is very simple. The model is the product. So over the past 3 years, foundation models has become the core source of value, the core engine that determines the capabilities and reshapes the entire tech stack. It's very much similar to the pivotal moment defined earlier in the computing era. And recognizing this shift is critical for deciding where to focus your talent, your capital, and your efforts in the AI space. So over the next 40 minutes or so, we'll unpack this in 3 phases. First, we'll explore why the model is the product and how the emerging capabilities create value that did not exist before. Then, we will briefly discuss why the ever smarter models absorb all of the surrounding complexities and simplify the overall system design. And lastly, we'll discuss how to navigate a difference between being a model-first company or a product-first company. So I grew up with the boom of personal computers, right? And back in those days, brands like Apple, HP, Dell, IBM, they fought for market share with slick cases, bundled software, and different form factors and features, and sometimes fighting on price, right? And during this era of personal computers, Intel and perhaps Microsoft Windows were the core of the innovation. And we got companies like all these PC makers building on top of the core intelligence stack, which is the CPU. And perhaps we also have companies like Apple building on top of Motorola CPU and have their own operating system, the classic Macintosh OS. And all these PC makers are, by definition nowadays, the wrappers around the silicon miniaturization, and they are all taking advantage of the exponential growth that's provided by Moore's law. And sometimes in the 1990s, the great company Intel even started an ingredient marketing campaign to make consumers aware that the intelligence is actually coming from the CPU. And they hold the real power. Sounds familiar? If we swap CPU for foundation models and we swap the PC makers for some of these wrapper companies, we're seeing the same exact value capturing dynamic playing out. The modern day equivalent of Intel are companies like OpenAI with ChatGPT, we have Google with Gemini, Anthropic Claude, Grok from xAI, and also we have some other very rapidly evolving open source players like DeepSeek, Meta's Llama, Alibaba's Qwen, or Mistral. And around these core engines of computation, core engine of value, we have companies building experiences on top of it, the so-called AI wrapper companies, right? We have the ChatGPT, the classic one. We have Cursor, Bolt, Perplexity, Lovable, Windsurf, you name it. And most of them are trying to differentiate based on a better user experience and tighter integration with the workflow and perhaps some prompt orchestration, prompt engineering. But none of these wrappers could exist without the foundation models that's powering all this. So just as the PC brands in the 90s wrapped all these computer cases and monitors and softwares around Intel CPU, this guys, the application layer wraps the interface and workflows around the foundation model. And the foundation model supplies the core capability, the core intelligence. And this is why the model is the product. If we circle back to the era right before ChatGPT, right? So this is in the time of, let's say, around 2021, 2022-ish. We have companies like Copy AI or Jasper, right? And what they did is users can go up there and fill out a short form, and with one click, you get a copy written, you have a copy written for you, and you can take that for further post-processing, editing, etc. Right? And everything changed at GPT 3.5. GPT 3.5 has the emerging capability that it's now being able to understand directives, keep multi-turn context, and respond conversationally. And this emerging capabilities enabled ChatGPT. And with it, we get a brand new product category. We have now conversational AI. And this boosted generative AI applications to the mainstream. It was not an incremental change. This is a step function change in terms of capabilities. And I still remember some of the hackathons back in the early 2023 era, right? That's 2 years ago, but that seems like decades long now. And there were a bunch of us trying to stitch together different fancy pipelines using frameworks like LangChain or Llama Index to provide and glue some of the code together to provide more context to the large language model so it can behave properly. And if we fast forward to June of 2023, everything changed. OpenAI released the tool calling API, which means the foundation models can now determine which tool to use by itself. And this solved one of the major pain points in building large language model applications. So for the first time, the model decides itself what to invoke to run a web search, run a database query, or and overnight, a lot of this glue code become very much obsolete. The orchestration logic move inwards inside the model. And this ripple effect was immediate. Now we have companies like Perplexity AI, which marries large language model to retrieval augmented web search to provide answers conversationally with up-to-the-minute reasoning, real-time knowledge, and some of the actions. And a lot of this were not commercially viable, was very difficult to achieve before the tool calling. So once again, one emerging capability in the model enabled and unlocked an entire new class of products. And if we shift our focus into software developments, again, in early 2023, you see like on Twitter or on LinkedIn, there's a whole lot of product demos, right? We get things like GPT Engineer, Auto GPT, Baby AGI, all this like fancy framework, and all of them are trying to do Agentic application running large language model in a loop. But most of them were very, very much brittle. It doesn't really work. Anyone who touched it, it doesn't work. And it's just pure demoware. But fast forward to June of 2024, Claude Sonnet 3.5 was released. And for whatever reason, it crossed a critical threshold, and we now have an emerging capability where the model can handle very long-running tasks, invoking tools, and conduct and plan across large code bases. And practically overnight, a lot of the agentic dev tooling becomes viable. Right. And soon after, Cursor launched YOLO mode, where you can just let the model decide what to do by itself, auto-accepting every single code change in real time. And at the end, you're just like, it works, right? And GPT engineer, previously the prior GPT engineer we mentioned before, they turned into lovable AI. So now we have a true no-code solution where you can write English and within unlovable, and it outputs some fairly nice looking and working web app. And there are also companies like Rapid, Vercel, they all provide some of this type of no-code solutions. And what's remarkable about this is this step function change in capability is not literally captured by academic benchmark. This is not captured by Sui Agent, this is not captured by Sui Agent or MMLU or whatever benchmark that people were advertising. This capability emerged in the model and it unlocked it materialized a lot of the dev tooling possibilities. And the pattern still holds, right? A step function change in the model unlocked an entire new class of potential products. And we see this same effect in image generation as well. So up until recently, if you want to edit a meme or or write a comic style avatar, you have to use like pro tools like Microsoft Paint to do your magic, right? And just this year, or last month, just last month, ChatGPT now integrated GPT-4o image generation. It's an autoregressive model, right? And all of a sudden, this single model just make a lot of these tools or the workflows obsolete. So instead of me going onto Paint, I can just prompt it, change 2017 to 2025, and it does the image editing just by writing one single prompt. And this redefines a lot of what it means by creative tooling. So now we have 4 clear examples, right? We have chat, tool use, advanced code generation, and text-based image editing and image generation. And every single one of this case, the model's new emerging capability created or enabled a new class of product category, and it's not the other way around. And this is why I kept coming back to the same thesis. The model is the product. Each emergent step function change in the foundation model's capability expand the frontier of the products, expands the frontier of what is possible. And there is actually also another very powerful consequences as model grows smarter. The complexity and structure of this models of the system starts to fade away, right? So as model gains intelligence, they naturally absorb a lot of the task and scaffold you need to put around them. Better instruction following capability means that you might not need complex prompt engineering in the future. Stronger reasoning reduce the need of a lot of very elaborate brittle agent frameworks. And multimodal intelligence means that you don't have to have a separate pipeline for voice, text, image, or whatever other modality you are dreaming of. And in other words, as the model grows smarter, the intelligence aggregates a lot of the surrounding complexities into them. So let's explore what this means. So let's revisit the personal computing era. Right? Back in the day, if you open up a PC, I still build my own workstations or computers, right? So like once you open things up, in the middle, like in the early 1990s, you have a CPU, you have a floating point unit behind it, you have a L1 cache, you have North Bridge, South Bridge, all these discrete components that's living on the motherboard. And they are all discrete components. Right? But as the CPU grow more powerful, they gradually absorb all those surrounding discrete components into the CPU. And even like in the, I think starting at Pentium, which is late 90s, the FPU get integrated into the CPU. The floating point processor gets integrated into the CPU, and now it integrates all the North Bridge, South Bridge, and even in the latest and greatest Apple M series chips, they even have the GPUs living inside CPU. And that is just tremendous. We talk about system on a chip. And in 2020s, if you hear some of the guys that's doing foundational model inferencing, they are now talking about system in a package. So instead of on the motherboard, they move all the discrete components into the CPU package itself. Or some of them are doing system on a wafer, right? That's, I forgot which company, but they do a system on a wafer. So the core intelligence is really aggregating all of the surrounding components around. And this is exactly, I think, what will happen for foundation models. And we can't really talk about foundation models without mentioning natural language processing, right? Like everything was historically NLP. And this is an image of the natural language processing textbook from Stanford from the 90s. If we take a quick look on the textbook, it spent 2/3 of the chapters and sections talking about syntax parsing, semantic understanding, representation learning, understanding grammar rules, and all those like co-reference resolution, entity recognition, and pages of very much engineered contents. And back then, to do NLP, we have to manually figure out each one of these steps before we can finally do what we need to do, which is either machine translation, dialogue systems, or chatbots. Right? It was complicated, it was brittle, and most of the time, it's really hard to make it work. And today, this is the textbook content, 3rd edition. Everything got absorbed by neural network. All the complicated syntax parsing and linguistic tasks got eaten by transformer. Right? Transformers ate the whole stack. And that changes the landscape of things. And if we step back and think about it, on one end, we have the raw data, the text. And on the other end, we have the task that we want to achieve, the actual outcomes. And previously, there were a lot of fake tasks that we have to do in the middle to pre-process, transform, or some handcrafted logic to bridge the gap. And transformer, the model, the smartest element in the pipeline, absorb all those tech into it. Right? And this is why the model is the product, because the smartest component is going to dominate the whole stack, dominate the entire pipeline. And we see this in modern day computer vision applications as well. So imagine if you are a online retailer, fashion retailer, and you need to showcase the model with a different color of the cloth, or perhaps you want a model with a different skin tone or different look. What you would need to do historically is either you have to reshoot to do a complete new photo shoot, or you have to hire some graphic designer using tools like Adobe Photoshop, or for me, Microsoft Paint, to change the color of the clothing. And some of this changed, right? Like in 2022, there is something called Comfy UI, where now you can put a lot of complicated, I guess, many different modules and stitch them together in a fairly complex pipeline. And this looks exactly like, I guess, a breadboard from Radio Shack For those who are old enough to remember that, right? You get all these components, put the components on the breadboard, and you wire them together. And now, in 2025, in this year, we just need a single instruction prompt, and you can do a lot of this image editing. So all the complexities you need to do on the left is now being replaced by one single text to image, or text and image to image model on the right. No pipeline, no stitching required, no more breadboards. So we just need a single English prompt or single natural language prompt, and you can get the results. And we see the same pattern playing out in the modern compound AI systems, as they call it. So let's use deep research as an example. A typical deep research system is built. First, you have the large language model generate a to-do list, a plan. And the model will go according to the plan to the web to do the research portion, and it's going to aggregate the information, put out a preliminary report, and then go reflect on what is missing, what else is needed, and update the plan and do that in a loop. And at the end, we get a final pretty summary outcome with a lot of different sources. And this is deep research. This approach, which we use large language model as nodes in a finite state machine or in a direct acyclic graph, has been the most common use case or the most common practice for building AI applications for the past several quarters now. But as the model gets smarter, some of these external complexities might and is starting to fade away. Right? So now increasingly, we are seeing one single intelligent agent, one of the smartest models, like currently Claude 3.7 or Gemini 2.5. It sits in the middle, and literally we're feeding it in a for loop. And the model is going to manage what to do next and execute different tasks or different actions autonomously. It can act, it can think, it can use a lot of tools for you, right? And there's even a thinking NCP that lets you that sequential thinking NCP that you can plug into some of these models. And this shift is already visible today in some of the more straightforward scenarios, like coding agents, the vibe coding stuff, right? The complexity moves inward from external workflows to the model's own core reasoning capability. So the consequences of this is this meme. OpenAI killed my startup, right? Every time OpenAI releases a new model, new features, a lot of the startup cry out loud and say, hey, their products are suddenly obsolete. The interesting workflows, the complex pipelines got absorbed into the new model. And this is the core risk. If your product's value is based on orchestrating functions around the model's current capabilities, each new emerging capability that surface will have a good chance of drawing your moat, will eliminate your moat. The model itself, the intelligence, has all the gravity. So this begs the question, how do we build lasting value? Given the realities, there are two strategic directions we can go into. Either we can be a model-first company, or we can be a product-first company. So the model-first strategy is, this is a quote from DeepSeek CEO. We believe the current stage is an explosion of technological innovation, not an explosion of applications. And this is the philosophy that drives companies like OpenAI, Anthropic, DeepSeek, and Google. They are all explicitly trying to build the most powerful general purpose foundation models. And the core belief here is that if you stay at the frontier and constantly unlock new step function capabilities, you get to define what products are possible. It's the equivalent of raising up the tech tree in Civilization or in StarCraft. You win by bringing a gun to a swords fight. And these labs pursue all this state-of-the-art models, racing towards like AGI, whatever that's defined. But this is not easy. Even for companies even for guys like Elon Musk, it took nearly 2 years and 3 model releases for Grok to be close to the leading edge, to be competitive. And nowadays, we're seeing a lot of these companies moving towards the application layer. OpenAI and Google both released deep research on ChatGPT and Gemini app to battle perplexity. And last week, or 2 weeks ago, Google released Firebase Studio, which is their version of Lovable or Bolt.new. Anthropic released Claude Code last year, and to go on against the vibe coding, the coding agent space. And even there are rumors that OpenAI is trying to acquire Windsurf, which is an application layer developer tooling company. So yes, model first give you the strongest hand when the model drives the value. But for most companies, this is very expensive, risky, and not always feasible. So now let's talk about a more realistic strategic path. How to be a product-first company, right? Let's think back at the very first iPhone back in 2007. The first iPhone was not built on exotic hardware. It used off-the-shelf components to build the iPhone. But what Apple did was they stitched these components together into an incredibly cohesive, delightful user experience. And this is the essence of the product-first strategy. How do you design, integrate, and how do you distribute? And provide a user-first experience. And in the AI space, all these product-first companies are focusing on leveraging the SOTA models, the state-of-the-art models, to build compelling applications and workflows. These are the tools or the containers or the surface that makes large language model useful in the real world. So these are companies like Cursor or Lovable or Perplexity or Windsurf, Klein, company of this type. And yes, it's easy to dismiss them as they are just OpenAI wrappers. But we do have to realize that for every single emerging capability, it requires a new interface paradigm. Just like autocomplete was not enough for modern coding assistant, we need new user experience patterns to unlock the full power of the foundation models. But the core challenge is that a lot of the product-first companies, you are dependent on the model-first lab to deliver these new capabilities. You don't get to control the underlying breakthrough. You have to wait for it. And when these capabilities get absorbed into the next model release, your differentiation might disappear. So where is the moat? There's a saying, first-time founders are obsessed with product. Second-time founders are obsessed with distribution. Right? And in the world of AI applications, the distribution gives you data, the user behavior data, the product feedback data, and some of the real-world signals to know what is working and what is not. And all this data are the keys to building your own evaluation harness or your benchmarking suites. And with the right distribution, product-first company can observe what the frontier models are capable of and what they fall short. And they can know this well before a lot of this show up in academic benchmarks. So as an example, Claude 3.5, Claude 3.5 enable a lot of the agentic coding or the vibe coding agents. And that no benchmark was able to capture that capability in the middle of last year. And the first benchmark that measures the long-running agentic task capability was released this year. It was 9 months after Claude 3.5 was released. And that benchmark is called METR, meter benchmark, for long horizon agentic task. And that is how far the academic or industry benchmark falls behind actual applications. So at the end, the distribution is perhaps not about go to market. It's about how you can build proprietary insights and early detection of model gaps and build your data-driven feedback loops. And this is the type of application layer intelligence that model-first companies don't have access to. They just don't. And there's probably one of the reason or rationale why OpenAI is talking to acquire Windsurf, because they have the data. And if we step back, on how to put this in practice, right? A lot of this evaluation harness and benchmarking mode is incredibly powerful because it allows us to solve AI system building with good old machine learning engineering. Right? So if we break it down, in a typical machine learning engineering scenario, we first identify the application and the data that's available, and we decide which model to use to model the agentic behavior. We can model it using a DAG, a direct acyclic graph. We can model it using a finite state machine, or we can put large language model in a loop, whatever people want to call it, an agentic system. And then based on our benchmark or evaluation, we figure out what is the objective we want to optimize. And we pick one of the algorithms to hill climb towards nirvana. Right? We can either use human level ingenuity to do like manual prompt engineering, or we can use some of the more automated way of automating the prompt engineering process using DSPy, TaxGrad, or one of the newer things that might come out. Or we might be able to leverage some of our historic data to solve, to hill climb towards objective using supervised fine tuning. Or we can define our own reward model and use RLHF or RLAIF to solve for the system. And the entire loop is how we turn our distribution moat into actual advantages and product improvements. And this is how product-first company can build a moat that model-first company do not and cannot easily replicate. And we're already seeing some of these companies applying these principles for their own AI system development. Of course, Apple has their own in-house foundation model as part of their Apple Intelligence strategy. Microsoft owns their own 5 small language models. And Perplexity has been fine-tuning or experimenting with fine-tuning Llama 70B or DeepSeek for their own retrieval augmented web search. And Cursor, right, originally known for the UX improvements for code search, they now hire some key players to improve and to help them to build their own foundation models. And this is despite all the very deep partnership of all these companies with some of the model-first company, the leading edge labs. And this help this company to remove dependency risk and position them to stay ahead of the curve, even though the model landscape changes around them. And in addition to all this shift in the landscape, we cannot not talk about DeepSeek. So before DeepSeek, we were, most of us, at least for me, I believe that training a frontier model was only possible for the biggest companies, the biggest players with a blank check budget. Right? And building reasoning capabilities at the level of OpenAI or Anthropic or Google is just fell out of reach. But DeepSeek changed that. It closed the gap between open source models and the leading edge closed source models. Before DeepSeek, it was roughly a 12 months or longer gap between the two. And when DeepSeek came out, it closed the gap to 4 quarters. The gap between OpenAI 01 and DeepSeek R1 is only 4 months. And this shows with the right team, approach, and resourcefulness, it's possible to compete against the frontier labs. And this also changed the strategic landscape. And nowadays, we have a lot of the GPU cloud companies that's making GPUs available. It's still a hot commodity, but it's much less exclusive than a year ago. And if we turn to the overall landscape, previously in the semiconductor industry, we have companies that's IDM that handles design, fabrication, packaging, and then we have the PC makers or the cell phone makers wrap their device around it. And with TSMC, it created 2 brand new industries. It created the design houses, which is the Broadcom, NVIDIA's, and then there's IP vendors like ARM Holdings. And we believe the same pattern is playing out somewhat similarly in the large language model space. So we still have the model-first companies, the OpenAI, the Anthropic, the Google of the world, that's building the full stack. And they are moving towards on the application layer. And a lot of the product-first companies are now moving onto the post-training phase. And at the same time, we have IP providers such as Meta's Llama or DeepSeek or Mistral. They provide IPs for the product-first companies to build on top of. And I think this is going to materialize clearly over the next couple of quarters. So the key takeaway is the model is the product. The emerging capabilities of the models define the product categories that's possible. And second is the model grows smarter, the structure matters less. All the intelligence will get aggregated into the model. And lastly, the distribution is the moat. It's the moat because you get to use distribution to build your own data, to build your evaluation harness, to build your own benchmark. So you know when a new emerging model capabilities arrive, you will be the first to market. Or if you are willing, you can use your data to create the emerging capabilities yourself. Again, my name is Han, and thank you for listening.